Alright, we're beginning 7.2. This is the first part. We're going to talk about a different way that a nth root expression can be written. So we're going to talk about how roots can also be written as algebraic fractions. So here's the rule. If you're taking the nth root of a, you can write that as a to this fraction 1 over n. So 1 over n is a power that a is being raised to. So what does this mean in layman's terms? When you talk about a rational exponent, that means an exponent that's written as a fraction. So this would be a rational exponent. So the denominator of the rational exponent is the index of the radical. And remember, index means what root you're taking. So now we're going to practice looking at some written in this new form and simplifying them. So if I've been asked to take 36 to the 1/2 power, the denominator tells me the root I'm taking. So this could also be written as the square root of 36, which is 6. Here we have negative 16 to the 1/4 power. So 4 is the root we're taking. Now what we need to be careful with is the negative is just a tag along, so it's outside of the 4th root. So the negative stays along, and remember 4th root means what number would we use 4 times to multiply to 16? So you would use a 2. 33 is negative 32 in parentheses, so that means the whole negative value is to this 1/5 power. The denominator tells us the root, so we are taking the 5th root of negative 32. Remember, we're allowed to take the odd root of a negative number. That negative will always come out of an odd root, so we get negative 2. Negative 2 is the number we would need to use 5 times to multiply to negative 32. Negative 16 all to the 1/2 power would translate to the square root of negative 16, which is no real answer because we cannot take the square root of a negative number. This one is the square root of the entire fraction, 25/49. We apply the square root to each number, so we get 5/7. Now what happens though if the fractional power we have has a numerator other than 1? For example, 3 over 2. So here's what we get to say. If we have a to m over n, like 3 over 2, the denominator still tells us the root we're taking, and m is the power on a. And it can be written either way. You could write a to the m power underneath the radical symbol, or you could take the whole radical symbol to the mth power. So what does this mean? The denominator of the rational exponent, this n right here, is the index of the radicand. So it goes here. The numerator of the rational exponent, or m, indicates what power you are to use on the radical base. So let's practice simplifying some of these. So this is how I feel best to do this. I'm going to take the square root of 100 first, and then I'm going to cube it. If I take the square root of 100 first, that gives me a smaller number to cube. So this is 10 cubed, or 1,000. So this here is negative 9 to the 5/2 power. Now the negative is not in parentheses, so it's a tag along. We just keep it out front. We take the square root of 9, and we take that to the 5th power. So the negative tags along. Square root of 9 is 3 to the 5th power, and so we get negative 243. The next one is negative 64 to the 2/3 power. Remember, the denominator tells you the root you're taking. So we're taking the cube root of negative 64. I always need to write my index if it's something other than a square root. So I need to write the 3 there. This is now to the 2nd power. I can take the odd root of a negative. Remember, the negative comes out. So this is negative 4. And that is then all squared. So I get positive 16. This one is negative 64 still, but it's 3/2. Again, the denominator tells me the root I'm taking. So this is the square root of negative 64, then to the 3rd power. Well, I can't take the square root of a negative number. So if I can't do this inside, I can't cube it. This whole answer is no real answer. I cannot take the answer. Now, before we can simplify any more of these, we need to pause and learn an exponential rule. So what we haven't seen yet on any of our exponents is a negative. So we need to talk about what we do if we see a negative. So we're going to learn the negative exponent rule, which sometimes is referred to the elevator rule. So an elevator only goes up or down, and that's exactly what the rule states. The rule states that this negative wants to be positive. So the whole base and the power would drop below the fraction bar. So we'd write 1 over a to the nth power. So this means a negative exponent simply means to relocate the exponent to make it positive. Negative exponents should never be left in the final answer. Notice, to make a negative exponent positive, you move the base and its exponent. So let's try out some that are not powers of fractions. Let's say 6 to the negative 2 power. So the elevator rule says that this would become 1 over 6 squared, which would be 1 over 36, because now you could take 6 times 6. This one here, what's the part with the negative 5 power? Just the y, so we'd do negative 6 stays in the top, and we would drop below it y to the 5th. Here we have a negative power in the top and a negative power in the bottom, so they will flip over. So we'd get b to the 4th over a to the 10th. Right, so now let's get back to exponents written as fractions, but let's put a negative with it. So here's how you're going to handle this. The denominator still tells you the root you're taking, and you're going to do that first. So you're going to take the cube root of 27, and this is to the negative 4th power. So cube root means what number would we use 3 times? So we'd say 3 to the negative 4th power. Now that negative 4 wants to become positive. So we put it in the elevator, and we get 1 over 3 to the 4th. Now we can take 3 times itself 4 times and get 1 over 81. So let's try 11. So we're going to take that whole fraction and cube root it. So we're going to take the cube root of negative 8 over 125, and then that whole thing is to the negative 2nd power. We can take the odd root of a negative. Remember, that just means a negative comes out in our answer. So we get negative 2/5 all to the negative 2 power. Now to continue, this negative power must become positive. So this fraction, when put in the elevator, will just flip over. So we'll write 5 over negative 2 now to a positive 2 power. So the power becomes positive because the fraction flipped over. Now every piece of this fraction will be squared. So we get 25/4. This is a 2 here, and you can try that one on your own if you need to. Now to finish up this first part of 7.2, it says convert from rational exponents to radical form. So that means change from seeing a power to seeing a radical. So right here we would have the 9th root of 3 to the 4th power. That's what we would have. This one here would be the cube root of 8x to the negative 5th power. And it says, again with a negative exponent, we would want to fix that. So we get 1 over the cube root of 8x to the 5th power. We would drop it below the fraction bar.